Okay, so in statistics now we're going to look at Unit 4, and we're going to look at discrete probability distributions. When we come back for Unit 5, we'll start looking at continuous probability distributions. So for our first section, we're just going to talk about the basic properties of a probability distribution. So the outcomes of a probability experiment is often a count or a measure. When this occurs, the outcome is called a random variable. So a random variable x represents a numerical value associated with each outcome of a probability experiment. Okay. The word random indicated that x is determined by chance, and we have two types of random variables, discrete and continuous. So discrete is when the random variable is finite or a countable number of possible outcomes. Okay. Continuous is when it has an uncountable number of possible outcomes represented by an interval on a number line. Okay, so values of variables such as age, height, and weight are usually rounded to the nearest year, inch, or pound. However, these values represent measured data, so they are continuous. So yes, we normally say that we are 18 years old, but really we're 18 years and 133 days. Okay, so that's what makes it continuous, not discrete. So if we wanted to decide whether the random variable x is discrete or continuous, and explain your reasoning. So let's look at the first couple. So let x represent the number of Fortune 500 companies that lost money in the previous year. So we're looking at the number of companies. Okay. So if we're talking about the number of companies, that's discrete. We're looking at the number of companies. And I think the easiest way to think about this is, can you have half of a company? No. All right. Looking at number 2, let x represent the volume of gasoline in a 21-gallon tank. So when you're talking about how much gas you have in your car, is it 1 gallon, 2 gallon, 3 gallon, or can you have half of a tank of gas? And the answer is yes, which makes this continuous. Because you could have 10.5 gallons. Okay, I want you to try example 3 and example 4. All right, so each value of a discrete random variable can be assigned a probability. By listing each value of the random variable with its corresponding probability, you're forming a discrete probability distribution. So this lists each possible value. The random variable can assume together with its probability. And we have two characteristics about a probability distribution. The first one is that each of our probabilities have to be within our range of probabilities, so between 0 and 1. And the summation of all of our probabilities should equal 1. So because probabilities represent relative frequencies, a discrete probability distribution can be graphed with a relative frequency histogram. All right. So if we want to construct a discrete probability distribution, the first thing we're going to want to do, so let x be a discrete random variable with possible outcomes. First, you're going to make a frequency distribution. For all outcomes. Okay, the nice thing about this frequency distribution is they're going to be just x values. They're not going to be a range or a class. Okay. Second, we're going to find the sum of the frequencies. Remember, this was our sample size or our n value. And then we're going to find each probability. F divided by n. Okay. Lastly, make sure you check that each of your probabilities is between 0 and 1, and that the sum of your probabilities equals 1. This last one, we can have some issues with rounding. Okay, and we'll talk about that. All right, so let's do an example. Constructing and graphing a discrete probability distribution. So an industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a score from 1 to 5, where 1 was extremely passive and 5 was extremely aggressive. A score of 3 indicated neither trait. The results are shown at the left. Construct a probability distribution for the random variable. So we're given all of our x values, and we're given our frequency. So that's step 1. Now we need to find the sum of our frequencies, which it tells us in the problem is 150. Okay, so to make our discrete probability distribution table, we're going to bring over all of our x values. And we're going to find our relative frequency or our probability. Okay, so F divided by N. So on our first one, 24 divided by 150. Okay, well, that's approximately 0.16. Then 33 divided by 150. We're going to say it's approximately 0.22. And continue that all the way down. So 42 divided by 150, 0.28. 30 divided by 150 is 0.20. And 21 divided by 150 is 0.14. Okay. All of our probabilities are between 0 and 1. And then let's check if we add these probabilities up, we get 1. Okay. What's nice about this table is now we can easily say, okay, the probability that x equals 2 or x equals 4, we just add those rows together. So we're going to add 0.22 plus 0.2. Which would equal 0.42 or 42% of the staff. Okay. All right, knowing our properties that x has to be between 0 and 1 and the sum of the probabilities has to equal 1. I want you to go ahead and try these two examples and determine whether or not they are a probability distribution. All right, now we're going to look at mean, variance, and standard deviation. So you can measure the center of a probability distribution with its mean and measure the variability with its variance and standard deviation. The mean of a discrete random variable is defined as follows. Our mean is just like the mean of our frequency distribution. So I'm just going to give you your formula. So mu equals the summation of x times p of x. And remember, when we round for our mean, round one more than the value of x. Okay. So the mean of a random variable represents the theoretical average of a probability experiment and sometimes is not a possible outcome. So if we take our discrete probability distribution from our previous example, and we want to find the mean score. So we have our x, we have our p of x. I'm going to add another row here, and let's just find the product of those two. So we have 0.16. 2 times 0.22 is 0.44. 3 times 0.28 is 0.84. 4 times 0.2 is 8/10. And 5 times 0.14 is 7/10. Okay. If we find the summation of that row, add those all up, we get 2.94. But then looking back at our original, we had no decimal. So our mean will have one decimal place, so 2.9. Okay. All right, so although the mean of the random variable of a probability distribution describes a typical outcome, it gives no information about how the outcome varies. So now we're going to look at standard deviation and variance. So variance, remember, is sigma squared, is the summation of our deviations, so x minus mu squared times p of x. And then our standard deviation is going to be the square root of that. Okay. All right, so we're going to do this example together as a class just because standard deviation and variance are probably one of the hardest to calculate. And we'll also review using Google Sheets for that. And then the last part we have with discrete probability distributions is the expected value. Okay. And the expected value of a discrete random variable is equal to the mean. Okay. So here we're going to use e of x is equal to our mean, which was the summation of x times p of x. Okay. With expected value, we're going to always make this round to 2 decimal places, because usually we're talking about money. Okay, so expected value is the probability that you're going to win. So think about the probability of winning a raffle, probability of winning the lottery. Okay, so although probabilities can never be negative, the expected value of a random variable can be negative, showing that you're going to most likely lose that raffle or lottery. Okay, so we're gonna do this first example and then we'll do the second one together as a class. Okay, so at a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 raffle ticket. What is the expected value of your gain? Okay, so first thing we're going to want to look at is our X values. And this is going to be our gain. Okay. So our gain. If we win $500, we had to pay $200 to win that. So we actually are only gaining $498. Okay. If we want to find the probability of winning that, only one person wins. So that would be 1 over 1,500. Okay. Now if we look at 250, our gain, subtract the $2, is 248. And that again is one person out of the 1,500 tickets. 150 minus $2 is 148. Again, only one person wins, so 1 out of 1,500. And then $75 becomes $73, and that's 1 out of 1,500. Okay, so here's the thing to be careful about. We know that when we do a discrete probability distribution, our probabilities have to add up to be 1. Right now, if we add these up, we would get 4 out of 1,500. Well, that doesn't equal 1. So we need to figure out what happened to the other 1,496 people. Well, all of those people lost. So they had a gain of negative $2 because that's what they lost. And that would be at the 1,496 out of 1,500. Okay. So now if we're going to find the mean, okay, we're going to multiply these together. I suggest you leave them as fractions just because it's a little bit easier to calculate. If you want to change it to decimals, that's fine. So if we do that, we have 498 over 1,500, 248 over 1,500, 148 over 1,500, 73 over 1,500, negative 2 times 1,496 is a negative 2,992 over 1,500. And now add everything up. Since we have common denominators, just add your add your numerators. So our summation of x times p of x equals negative 2,225 divided by the 1,500. And if you divide that, and we round to our 2 decimal places, since we're talking about money, we have a loss, because it's negative, of $1.35. So if you do this raffle, your expected value or expected win will be a negative $1.35. And the larger that negative value, the more likely you're going to lose. Okay. If it's 0, that means you're going to break even.